Alright, we're back with a rare evening stream. Okay. And let's try something different. I'm not going to do AI today because I'm getting kind of tired of AI. Instead, I think it's time we get serious. No more messing around with stuff. We need to learn Rust. So let's learn some Rust and let's mess around with Rust a bit. Alright, so what the heck is Rust? Well, let's see. I'm gonna use Rust by example. And this other thing called Rust links. But I think the nice thing is we gotta do the super basics because I don't even have Rust installed in the WSL thing. I don't have Cargo or Rust C. Okay, so I don't have anything. Actually, I don't even have a C compiler, GCC or Clang. So let's do all of that from scratch first, which should be pretty easy. Install Rust. Yes, we are a Windows subsystem for Linux user, so we're exactly this. Oh no. I guess I need GCC first. Does WSL not install a C compiler? Interesting. It actually doesn't. Compilers build extension, debuggers are omitted. Okay. So I guess we need this. I wonder if this is for Rust links though. No, let me do the Rust thing first. So first we copy this. And I just do enter. That should be it. Alright, let's see what is this one here. Welcome to Rust. This will download, yes. Yup, Cargo. This will run. It looks like an existing Rust up settings. Oh, I didn't know we had this. Interesting. Do I have Rust up then? Oh shit. Terminal, new terminal. No, I don't have Rust up. This is, I don't know why I have that folder. Let's see what's in this folder. Maybe I can delete it actually. What the heck is going on here? So, settings toml. I think I'm gonna delete this actually. I don't like what's going on here. So cancel installation and do rmrf rust up. What else do we have here? Bash history.net, GMPG, Keras. Okay. Again, Rust. Okay, I guess the installer is bugged because it creates that. Interesting. Well, not a good start for, not a good look for Rust, but sure. I don't know why I get these warnings where I literally just deleted this, but fine. Default host triple, yes, this looks good. Stable default, yes. Modify path variable. Enter. Okay, Cargo, nice. The Rust compiler. Aha. No default linker. Damn it. Was found in your path. CC. Many Rust scripts require a system C toolchain to build. Okay. So now we finished Rust. We do have to go back here and do sudo apt install gcc. I hope this is going to put it into path. Yes. Okay, so it's a bunch of GCC stuff, which we definitely need. I'm surprised this doesn't come with the base image. Alright, so now we have a thing here, and if I do new terminal, okay. Do I have CC? I do have CC, okay. And I have Rust C? I do have Rust C. We're pretty good, and I have cargo? Yeah, okay, we're done now. So we have all the Rust. So that was pretty easy, just install a C compiler and the Rust. Now we need to install Rustlings. Cargo install Rustlings. Okay, it has a lot of dependencies, interesting. Sure. All right. After installing, run the following command to initialize the Rustlings directory. Okay. Yes. Nice. Hey, doing pretty good. Thanks for joining. I'm kind of tired of all the AI stuff, so it's gonna be Rust for a while. Probably with video game development or something. All right, so now we have the Rustlings folder. Oh, I see, and it has exercises and solutions inside. Yes, we also want to install Rust Analyzer official tool. Yup, there we go. Our general recommendation is VS Code with the Rust Analyzer plugin. Okay, I'm gonna install this. Yes. I think it's pretty good. I heard a lot of good things. Rust is really supposed to be really good, and I already like it because it was so like I just installed it for the first time on this machine, and it took like 3 minutes ever since I started stream. But then of course, oh nice, it has a bunch of exercises, so I'm just gonna start going through these. Interesting. I think it's definitely going to be more popular in the future. All right, so let's start Rustlings. And I do Rustlings. I like C. Not even Python has this. Like they have official examples and learning guides. Is this your first time? Don't worry. Rustling is made for beginners. We're going to teach you a lot of things about Rust, but before we get started, there are some notes about it. The central concept is that you solve exercises. These exercises contain some compiler or logic errors which cause the exercise to fail compilation or testing. It's your job to find all errors and fix them. Okay, because obviously Rust is very compiled, like a lot of checks are done at compile time, right? Make sure to have your editor open in the Rustlings directory. Rustlings will show you the path of the current exercise under the progress bar. Open the exercise, fix and save the file. Rustlings will automatically detect the file change and rerun the exercise. If all errors are fixed... Oh damn, but we need the guide too because I don't know the syntax. Alright, so let's see what the heck happened here. Intro RS. Oh, I see. So each of the exercises sends you to a link. Rust uses the print and print line macros to print text to console. Okay, even this I know. Print line is a print with a new line after. And print is just a basic print. So this is an empty line. Yeah, so we should see exactly this, obviously. I guess let's start. Let me read the guide too then. Okay, so this is literally the first. This is a comment. Okay, so comments are double slash. You know, it's interesting you asked that. I think so. Here's the thing that I also learned at work a bit. I think yes, and I think Rust is a really good example of why. I think AI models these days, they work better on Rust, or they definitely will in the future. Just because the syntax is more strict. So like it has, if the AI gets something wrong, it's easier for to get compiler feedback versus like C or other low-level languages. But other than that, it's also performance. Like you need either Rust or C for performance. I don't think anything else is gonna fly. Like that's why even UV itself, the Python tool, is written in Rust, just because they want it to be so fast. So there's really no escaping performance. And then if it's C versus Rust, I definitely think Rust is gonna win for sure. Okay, so we can add our own print here. Hello from the stream. And this should just print a new line. Okay. And then the basic print will keep continuing. This is on the same line. Whoops, sorry, semicolon, because it's a compiled language. No, because the print prints a new line at the end. So this is a new line. And now if I do another print, this is on the same line. And semicolon. Okay, so as expected, right? So prints hello world and the new line. Then this one prints hello from the stream. Then this one prints this is a new line and nothing else. Okay. I don't know about Python is slow though compared to, I don't know about JavaScript. I don't think anything can beat C or Rust though, like for low level system stuff. Also, I know for sure that Anthropic is training on Rust. If you look at what the Claude models are doing, they have a lot of Rust examples for some reason. Like there's even this famous example, rewriting bun in Rust. So this came out a few days ago, and this is actually from Anthropic itself. And, you know, because it says bun was acquired by Anthropic recently, and they use Claude Fable to rewrite this, whatever this thing is. It's like hundreds of thousands of lines of code. And it was written in a language called Zig, but then they rewrote it to Rust. So then you can ask, like, why didn't they rewrite it to Python or JavaScript? It's the speed and the compiler. Yeah, it's not for web. Okay, fine. Yeah, for web, it's, I'm talking more about like, so what I want to do is lower level, like for example, a video game engine or any sort of calculations or stuff like that. But also interacting with hardware. That one has to be C or Rust. But yeah, Python is good. Yeah, it is true. All the AI models know Python. Like Python is basically solved, but it is, it is slow in general, and it's not good either for, I mean, it's good. Python is good for everything and for nothing at the same time, right? You can also do web dev in Python, but I'm pretty sure not a lot of people do that. All right, so we know how to print in Rust, and these are macros because they have the exclamation mark, which I guess there's, okay. Oh yeah, it's a macro. Okay, we're gonna have to learn about how to write macros way later. Okay. Oh, comment varieties. Let's see. Line comments. Start with double slash and continue to in a line. Block comments. This is Python style. Or something. Or no, it's C style. Dot comments. This one is a new one. So what? You can... See, this is why it's so nice, because you can automatically build docs using cargo doc. Interesting. Okay, so regular block comments. Okay, formatted print. Actually, maybe we're ahead of the... I think we're ahead of the thing now. Let me go back to... no, we're not. So what do? Do I keep reading the guide or... Okay, fine. Let's read the formatted print. Printing is handled by a series of macros. So we already saw print line with new line. Print is the basic print. Format writes it to a string but doesn't print it. Where string is one of the two fundamental string types in Rust. Okay, well, let's not jump around too much. Okay, and ePrint is for error printing. Yeah, Rust is definitely in the top there. And my personal prediction is it's going to overtake C in like maybe 5, 10, maybe 15 years. But it's definitely here to stay. I think C# is a bit higher level. Actually, maybe what I'll end up doing is it'll probably be a mix of C# and Rust. But that'll be much later. We gotta learn the Rust first. Alright, so there's a bunch of prints here. So there's a compiler. So 31 days. This is exactly like Python syntax, like placeholder, identifier. I see, they have indexes. So 0, this is 1, 1, this is 0, or 0 is Alice, 1 is Bob. Subject, verb. Oh wow, it has named arguments too. It's exactly like Python then, yeah. This is pretty nice actually. Base 10 binary for building a website. Yeah, web JavaScript for websites for sure. What the heck is Python good for? It's good for everything but nothing. Yeah. You can write justify text. Okay, print is getting pretty complicated here. You can pad numbers with extra zeros. Left adjust by flipping the sign. You can use named argument and the front is having a zero width. So I can never print if I call this width. This doesn't work, obviously. Like, what if I want to print width? What if I want to print something called width with a dynamic width? Okay, so we have to fix this example because it's referencing a 1 that doesn't exist here, so it needs 2 arguments. Yeah, we can't do this, so we can't mess around with it. It has to be like my or arg width. Does underscore work here? It does. Okay. Interesting. So this is padded with 5 zeros, right? Yeah, it is. Through the, oh, I see, push to the right and pad. Okay. What's happening with this struct here? For Rust 158 and above, you can directly capture the argument from a surrounding variable. Really? So if I call this something, I can print something with, I guess, an arg width of 4, 1.5. No. Ah, I forgot the dollar sign. It's the special dollar. Yeah, it works. What the heck does this do? 6? It pushes it to the right? Yeah, it does. It pushes it to the right, and I guess it adds some zeros that are not shown here. Ah, because we need the 0 syntax. Okay, so for floating points, it puts them in the front, and if I do this, it should put 1.500, it should put after the decimal. Yeah, okay. This is pretty helpful, actually, so we can align numbers to the left. So what if I ask for 4 decimals? I guess 4 characters. Oh, these are not decimals, these are characters. And my number is 1513. It has more than 4. Okay, there's no truncation. 5 shouldn't do nothing because it has 5 characters. Yeah, and then from 6 onwards, it should put a 0. Yeah, okay. So it's not quite truncation. Oh no, sorry. This is what I wanted. So add a print line macro call. Okay, let's do this exercise then. So we can say print pi with a limited number decimals. So I guess we can do let pi for, which is like 14159 something. Okay, and now we need to print it. Then we can print pi. Of course, I have to put semicolon after everything. Okay, so this prints the whole thing. Yeah, we don't know how to set number of decimals. How the heck do we set decimals? Dot decimals dollar. So it's semicolon. Okay, it's colon. Dot 3. Okay. Okay. So we can do decimals dollar. Decimals equals 3. Should be the same thing. Okay, or we can do 4 or 5. And what happens if I do more? If I do 10, does it put zeros? It doesn't, because well, it's floating point. Interesting. If I do this in F64, is it? So in F64, it is exactly. Well, we don't know if it's exactly representable, but no, it's not. It has something there for sure. What if I put something very large? Like, does it? Because it must stop at some point, right? Yeah, it does stop. Okay, so then if I go beyond precision, it adds zeros. And I guess, for example, 1 is exactly representable, so it should be exactly 1. Yeah, okay. All right. Well, I'm pretty happy with this. Debug. I think it's getting too... So we can print with colon question mark. Numbers is not going to do anything. Argument 1. Christian Slater is the actor's name. But interestingly, this prints the quotes too. So if I take this off, okay, so there is a difference here. Hey, thanks for joining. Just messing around with some Rust stuff. No more AI for a while, at least not on live streams. All right, so the thingy here makes a difference because if I add this, I see the underlying type too. Oh yeah, I just started like literally half an hour ago. Like I'm basically at Hello World still. So you're probably way ahead of me. Okay, so we can also print the structure, but it prints it exactly like it is. So structure 3. Yeah, so this, if I call this, okay, well, never mind, because, okay, now deep structure. I see, so it's a structure, deep structure. I can have, okay, so I just need to derive debug. And I can have deeper, deep. And I'm guessing this will print the whole chain, right? Probably pretty easy. Deep structure. Oh shit. What's happening here? Oh, I have to. Okay, I see. I also have to create one, so I need to do the whole circus here. Structure 42. Okay, well, this is easy, but there's a question here. The problem with derive is there is no control over how the results look. What if I want this just so a 7? Well, we didn't get the structs yet. I don't know the syntax, but I'm guessing you want to implement this trait or reach into it somehow. Oh, pretty printing. So what happens if I put a hashtag here? Okay, it looks different. Still doesn't answer the question, what if I just want a 7? We'll see later, because we have to get the struct. Okay. Display. Format debug. Okay, so this is the issue there. Customize the output appearance. Ah, okay, so actually they teach us right now. Implement display for a custom structure. So you need to have this signature no matter what you implement it for. Format display may be cleaner, but this presents a problem for the standard library. How should ambiguous types? Yeah. So I'm guessing it's left unimplemented. Yeah, okay. So display is not implemented for vector. All for generic containers. A structure with 2 numbers now. Display just writes both of them as a tuple, like a Python style. I see self.01. These are positional. Okay, we need to learn about structs first. This guide is kind of getting a bit ahead. Requires format binary, which hasn't been printed for. I guess we can do our own here. So let's do a deeper one then. Let me try this. Derive debug. Struct plane. Let's say it's a 2D plane is defined by 2 points. So P1 point 2D and P2 1.2D. Does this build or? Yeah, it does build. Okay, so now we need to implement display, which has, this is a fixed signature, but we implement it for plane 2D. And if I got it right, then this should both points. What the heck is up with right here? Rust, right macro. Okay, so I have to manually write to the buffer. So then can I write to F P1? I think this should work because then the display method should flow through this other one. Maybe not though. So I can do let P1 and I can let P2 equal some other point, 2.3 and 1.2, and then I can say let plane 2D. I guess this works. Again, I don't know the struct syntax. I'm jumping way ahead here probably. Let's see. Yeah, it works. Okay. And if I print line, here's a 2D plane. Oh. So I need to print it in display mode. Yeah, display. Plane. And debug mode, we know what it's going to be. It's just going to be the raw. It's going to be a mess, basically. Okay, I can't type the question mark, which is insane. This website has something. Okay, it actually worked. Yeah, so P1, the print for P1 triggered the print for a point, which is X, Y. I guess, can I put like double? Or maybe I want like escaped ones like this. I'm assuming this is how you escape these in Rust. Okay, so then now the print looks a lot nicer because it says P1 is a point with this, P2, so this is a plane. Okay. Alright, so we implemented our first trait too, which is like, we jumped way ahead, but it's fine for now. Okay, we did a harder example than complex. Adding a space is easy. Damn, I feel like this guide is going kind of crazy. Maybe I'll skip this one. Because we have to go into Vex now. And references, like... I'm gonna skip this one a bit. Formatting is like, this is what, 3 decimals, I'm guessing? Yeah, 3 decimals. Octal, hex, a bunch of stuff. Okay, we're done with Hello World. Okay, let's read the primitives. So Rust provide exit primitives. I gotta get some water. Hang on. Be right back. All right. Okay, what's going on here with the primitives? Okay, well, these are pretty basic. Signed integers, 8-bit, 16, 32, 64, 128. Pointer size, okay, we don't know what a pointer is yet. On-site integers, obviously. Floating point, we've seen them. Char. Char is 4 bytes. Not 8? Is a C char 8 bits? Not necessarily, but most of the time, yes. Okay, well, this is the difference. So I guess it's we can represent even weird characters directly in Rust. Like in the editor. Wait, so I could have printed weird things then? If I go and I print infinity. Yeah, I can. Interesting. So it has it directly. Okay, well, this is nice to know. Boolean is obvious. Unit type is empty. Okay, that's it. Okay, compound types. Array is bracket. Tuple. Okay, well, this is literally Python, basically. I mean, at least syntactically. Variables can be type annotated, so it's a bunch of variables. Boolean. I see, so integers default to 32, floats to 64. Also very good to know. Oh, it works like that. Oh, this looks horrendous. Like 5i32. So I can also do what? Let b float 2.32 f64. Wow, this looks really bad. I'm never doing that. Okay, there's some mutability stuff here, but again, it's jumping ahead. Like, what the heck is mutable? Yeah, so you can't change the type of a variable. You can't make an... I guess okay, so we're always gonna annotate stuff. Like yeah, so it's insane not to annotate, so... it should be i32, then obviously you can't set it to true because now you know it's a bool. I see, you can shadow variables. Again, we need to annotate this because we're sane. Oh, but it works like this too. So this is not i32. If I put this here, it's wrong. Because this is higher than the i32 max, right? Well, I can't change its type, so if I just put the number here, I'm guessing I'll get an overflow error or something. Oh, no, I'm not. Oh, yes, out of range. Okay. Okay, well, this syntax is horrible. Like, why not just put i64 here? Why would you let the compile, like... Yeah, this is not good for programming, right? Because you want to know what this is ahead of time. I mean, it's good to know this works, but we're never doing this unless... Let me do it this way. Why would a reasonable, skilled, clean Rust programmer ever not type annotate and let the compiler infer the type? Something is horribly wrong here. If you explicitly annotate every single variable, your code becomes brittle. Why? Because I have to change by letting Rust infer the types? I don't think I buy this. No. Reducing visual noise? Maybe. This is the real case where you're forced to do this. In Rust, some types cannot be because they don't have a name. Okay, I'm not convinced. All right, we can leave this for now. Literals and operators. Integers, floats, characters, strings, booleans, and untype can express literals. Integers counter to hex. Okay, underscores. Okay, this I like. This is exactly Python 2. So you can represent large numbers with underscores. Yes, somebody is definitely getting into Rust. Thanks for joining. We have to do it. I'm tired of the AI stuff. I gotta take a break from all the agent crap. Yeah, so thanks for joining both on Twitch and YouTube. Yeah, I just started like 50 minutes ago. I know a bit from some other experiences, but I want to start clean. I have the Rustlings ready too. But I need to understand the basic syntax. All right, so E notation, we know this exactly. Python, also F64, which I guess you can't change, but it's fine. What do I want to build in Rust? Well, like I said, I would like to do maybe some game development, like a browser game with the backend in Rust or something like that. So instead of this awful, yeah, that looks okay. Yeah, I saw it. Oh yeah, I saw it earlier. There's like some horrendous stuff where it says like, yeah, like the 5i32. Like, why would you not do like i32 equals 5? Like, I'm never doing 5i32 unless I'm missing something. Not sure what they're thinking here. And I was just ranting about this inferred type, which looks even worse to me. Like, why would I not do i64 here and rely on the compiler to... Right? Because I'm not insane, you would think. This seems horrible because you're delaying the type inference. Yeah, I figured it's got to be for much more complex types, but these examples kind of throw you off. All right. And this one is weird again here. So if I want to print 1 plus 2 with literals, what happens if I cut this then? I guess it's i32, the default type. So I get... so I'm going to suffer with overflows, right? If I don't use u32. I'm going to overflow earlier if I leave this. Yeah, it's i32. So this can bite me with overflows. This one can be omitted then. This one is... try changing to U32. I'm guessing this will be a wraparound or capped. I don't know what the default behavior is, but it's... Okay, so it also panics on overflow. Or no, it's not a panic, sorry, it's a compiler error. Which would deny... Yeah, Rust, I know, I didn't think the compiler would catch this. I thought it would saturate or wrap. But it seems somebody enabled deny overflow. I guess it's by default, so you would have to what, allow like this, right? Yeah, there we go. So okay, so now I have a panic instead of a compile error. Yeah. Yeah. Well, yeah. Yeah, so I managed to turn it into a panic, but you can just allow it apparently. All right, so let's go back to I. Scientific notation is pretty boring. Oh shit, the operators. I guess these are Python-like, right? This is... Yeah, these must be Python-like, but we'll get to that later probably. Wait, no, where are the operators? Oh, I see, in Rust. Oh, okay, so we have to read all this stuff. Okay, so unary. Hey, thanks for joining on Twitch. Rust is the best modern C++ keyword. Something like that. Wait, so what's happening here? Yeah, that's gotta be a meme or something for sure. It's a joke, right? I don't get it either, but it sounds like a joke. I'm definitely sold on Rust. Okay, let me get rid of this. Hang on, what's happening here? So true and false is false. Okay, so these are the late, and these are exactly bitwise, like C and Python. Wait, why do I need U32 here? What the heck? I need a specifier for... Oh, yeah, I got it. Like this, right? But, yeah, so I can do this for free. Yeah, it looks better for sure. Why do I need U32 for binary ops, though? What's happening? Why do I even need a type? Isn't this just like raw bits? Or... No, it doesn't work that way, right? It's... I mean, it does work. So what's the difference between I32 and U32 here? There's no difference, right? There can't be. Because they're both bitwise. Can I put F32? No, I can't put F32. That doesn't make any sense. Yeah. Yeah, I guess they're trying to teach you some practices, but this one looks weird to me, right? Because if I want to do raw... I guess the implication here is that there's 32 bits and the others are... The leftmost ones are 0. So it's as if I had written 32 bits here. Okay, all right. One shifted. This is a shift, right? Left shift. Yeah, it's a shift, obviously. So I can shift with 4 to get 16. Yep, that makes sense. If you just want a bitwise, yeah, because the oh, wait, here's another one. Can I do then? So that means I can also do unequal number of bits on each side because it left pads it all the way up to I32. Yes. So if I do just like 1 here and I see the AND. Yeah, okay. Okay, so now I see why it needs the type, because if I put a 64 here, this should also work. It's not gonna make a difference, but it pads all the way to 64, I would guess. Okay. Shifting is easy. Shifting is easy. In hexadecimal for some weird reason. Yeah, like for shifting, it makes it easier to see for sure, because I divide the 8 by 4. Use underscores. Okay, this is pretty clear. I guess we need to read about... Probably there's a bunch of stuff with pointers, which is... Okay, I guess we'll have to learn this by force. It's fine. Let's not get into it. Okay, tuples. A tuple is a collection of values of different types. Sounds very Pythonic. Tuples are constructed with parentheses. Yep, it's exactly Python. You can put everything you want. I've seen it, but yeah, I think we have a way to go there. Yeah. T1 types of members. Function can use tuples to return multiple values. Okay, so this is very Pythonic, basically, right? Yeah, let the pair. I see, so you can even unpack a tuple with exactly the Python syntax, which is pretty nice. So this is unpacking and then repacking. Okay, so now they want a matrix with 4. There's a ton of stuff here. Boolean, string, floats, blah, blah. Okay, tuple indexing looks horrible. Like, what the heck am I supposed to remember that the 15th value is whatever? Yeah, it's very Pythonic. You can tuple tuples. But how do I address stuff? Is it just the number, the position? Because this looks pretty bad. Very Pythonic. Reverse applying the function. Yeah, okay, interesting. So long tuples more than 12 elements cannot be printed. This seems like a random thing, but sure. I guess you actually can't have 13 things. But you can have... Oh, sorry, I forgot to do the things. Oh my god, it's actually not... Yeah, they didn't implement the trait debug. They stopped at 12. Interesting choice. I guess this would work. Interesting choice indeed. Okay, so then we have a matrix with 4 floats and print the matrix activity. Oh my god, okay, this is the first exercise. All right, we got to implement the format. The problem is I don't know it by heart, so I have to look at what the format signature is here. There's no way I can... It's this one, okay. So we implement for matrix. And I think it was the syntax was you have to write to the buffer F. Yeah, lifetime. Okay, I'm a long way from lifetimes for sure. Hang on. I don't even remember the right syntax. So how can I write macro Rust? Let me do it the principled way. The problem is I didn't get to the macro part either, so I'm not familiar with the macro syntax, so I can barely read this. I have to look at the example because I'm not familiar at all with the macro. And also I don't know what the $sign is either. Yeah, my biggest problem is I don't know how to read the documentation. Okay, so you just write, and then the next 2 arguments are the string, and then its arguments, if any. So it's just a formatted string. Okay, so let's go back here then. So what do I need to write? Yeah, that's what I don't know how to read the documentation. So it's f format args. Yeah, that's what I was looking for. Okay, so what do I need to write? So they want the matrix to be printed. Okay, so then we're gonna write a pair of round parentheses, and then it's just one value, comma. Is this what they want? No, space. Okay. And then new line, the other thing. Yeah, I think from my vague understanding. Well, you know what? That's a good... I actually found something that they do have variadic functions in the nightly now. Yeah, so I have to do horrible here. Like, there's no way, right? 0, 1, 2. There's no clean unpacking, right? Like, Python would have... Python has, if you have... I'm just going to write Python, but if I have x is 1, 2, 3... If I do star x, it unpacks them as var args. I guess this doesn't exist in Rust. There's no star self. So this would give you 1, 2, 3, but as var args. Sure, so I can do let But then I have to create 4 variables again, right? Like, what do I say here? Upper left. And then I do 4 of them. I guess the principal way is to do like, okay, we have to do a for loop or something, but we're nowhere near there. So hang on. So I think this should work. I think. Okay, I know what you mean. No, hang on. So you can create variables in the format function. Actually, you can do something a bit cleaner, because I can say like upper left, and I can at least do this. At least the var args work like this, right? Yeah, because they taught me in the Hello World. So this looks kind of more human. Although it's still pretty bad. Yes, they teach you about padding, but they're actually, yeah, I think the padding is with the dollar symbol after or something. Okay. Also, I don't have Rust format, so this looks horribly formatted, but yeah, I guess I'll do it like this because I'm used to Python. Anyways, well, maybe like this. Okay, we'll do it like this then. Am I allowed to put a comma here if I want liberally, or because I'm used to adding? Like coding wise, you mean? The background stuff like that, or? Yeah, coding wise, it's a lot of Python. Like I did my PhD in generative models, but it was like a Python festival, and even today it's a Python fest. But a lot of scientific compute too, so pretty low level Python, but still Python, like from a syntax point of view. All right, so let's see what the heck do we do here. Yeah, because I'm used to Python. Like this looks cleaner to me. Okay, so hang on. This is the debug print. So now I need to add the display, the pretty print, right? Let's see. Yeah, so I need to import the... what the heck does it want me to do? Oh, I need to use standard FMT? Interesting. What did the Hello World have? Oh, yes, I need to use standard FMT. Okay, okay. Oh, I don't need to put a semicolon? Oh, I don't need it. It wants the return. Okay, this worked. Finally. Okay. Gabor, PyTorch, Pro, libtorch, and see it. Yeah, exactly. Well, actually, this is where I want to... Well, the funny thing is I read this... If I learn Rust, I really want to do it the right way. I want to do like type-based design and all that stuff. Like no more runtime checks. Just burn everything encoded in the type system. I saw this post a while ago, which is playing chess in the Rust type system. I mean, this looks horrendous, by the way, but it's. I would like to get to the point where I can think about and understand this, but it's like I mean, you know what this is. It's purely from the compiler, which is insane to me. Like, it's all types. Like, there's no runtime code at all, right? The main is just... yeah, it's really bad, but then it's also like, it's stretching your Rust understanding to the maximum. Like, all the types and everything. Like, they encode the board state completely in the type system. Like, there's no actual prints or operations. It's all... it's really bad. Like, it's... yes, it can. I mean, it's... I think this repo is... yeah, it's exactly in both of them. Rust and TypeScript. But then Rust is nicer, right? Might as well do Rust instead of TypeScript. Yeah, check this out if you... I saw this a few months ago, and it kind of stuck in the back of my head. Like, I would like to get to a point where I understand it at least. All right, so tuples were done. We met, okay. I guess I wonder if I missed something here, because this is a tuple. I guess they use a struct here. I don't know what happened here. It's like they want you to print. Okay. Oh shit, add a transpose function using the reverse function. Okay. All right, so let's add a transpose. And it works on the matrix. I guess they want it to work. Returns the matrix in which two elements have been swapped. Okay, so matrix. I don't know how to implement this other than the dumb way, like, because they don't give you. So I'll just do let result matrix. No, I can't. Yes, it is. It's a matrix. I mean, I'm just gonna write it out, right? Matrix 0. What is it? It ends in 3 and it does 2, 1, right? That's it. And I guess result. I don't even need. This is all I need. It's a single line because unterminated is a straight return, right? So then I can do print. Well, no, I can do let transpose. Oh, it does? It doesn't know how to return, so I need to do this and then result. Okay. Okay. So then I do let transpose. Again, my preference is to annotate this. See, like, I wonder why don't they annotate this here? I guess it does become annoying. Now, I'm going to annotate this. So this is a matrix, which is transpose of the matrix. And then we can pretty print transpose. Also, I need to semicolon. I always forget because I come from Python, obviously. Yeah, that's true. I'm working in the. This is not, I don't know what, the web editor. So I gotta move back to Rust things. Okay, so this worked pretty nice. I mean, of course, there's no mutability, no. So this is easy Rust. Okay, we're done. Arrays and slices. This one sounds important. Thanks. Yeah, thanks for sticking around. An array is a collection of objects of the same type. Okay, so not the tuple, an array stored in contiguous memory. Arrays are created in brackets and their length, which is not compile time. Okay, so you need to know the length at compile time. Slices are similar to arrays, but their length is not known at compile time. Instead, slice is a two-word object. Oh, I see. So it's actually a parameter. Okay, so this is the, like in C, how you would carry around the start and the length. They just give you a... Slices are fat pointers. You mean even the first word is a fat pointer? Or no, the whole, both of them together, they form a fat pointer, right? Yeah. No, fat pointer. Okay, so anything with metadata. Yeah, okay. So then this is the raw part and then the metadata, of course. The word size is the same as usize. The processor. Okay, sure. Slices can be used to borrow. Okay. I'll have to read about the borrow checker at some point. Well, shit, it wants me to go in borrow checking. Slices can be used to borrow. Slice length. Okay, so it's a non-mutable borrow, basically, and that not a mutable. Okay, so this is shorthand for repeat. And yeah, okay, yeah, oh, okay, I see. So yeah, that's the thing, I barely know the syntax. So, okay, so as long as the mute is not present, then we're not into borrow checking yet because, well, we are, but we can't mutate. So let's assume the code is easier. Yeah. Okay, so I can print, and of course, if I try to print out of bounds, the compiler catches it. This one is easy because it ends here. It ends at 5. Well, it ends at 5, so yeah, okay, out of bounds. Obviously. Length returns number of counts in the array, which I guess is just a convenience because it's already known at compile time. Arrays are stack allocated. Right, because it's known at compile time, so it's not on the heap. Arrays can be automatically borrowed as slices. So the reference to XS. So when I type this, it magically becomes a slice and it has dot length. Oh no, it has it here too. Oh wait, so the array also has the length metadata. Oh, they mean like... because, okay, so I don't have to write a 5 here, obviously, because the function would be useless then. So this is a generic slice now. Okay, I see. So it's just a syntactical help here to write a generic function. But now this function does not know the... So if I try to print inside here, then what happens if I print infinite element? Because now, does the compiler know how to track this? No, it's a panic now. Okay. Okay, this, I feel like this is pretty subtle though, so I can write a function that takes a slice, but I lose the... I lose the compiler check, but of course it's still memory safe, so I get a panic. Whereas here, if I did it, of course I would have gotten the compiler check. Okay. Slices can point to a section of an array. Ah, okay, this one I understand. So I can take just from 13 to 44. And if I print the length of this inside, it's gonna be like 44 minus... Oh, this is Python notation, right? So it's from 13 to 43. So 44 minus 13, 31, yeah. What does that mean? Start ... equals... Know what you can do? Start ... equals end. Oh, inclusive. Oh my god, that looks horrible. Okay, I'm never doing that. Yeah, okay. Why would you ever do that? Isn't all the... I mean, I come from Python, so I'm used to the 1-4 notation. Okay. Oh, thanks for joining on YouTube. I want to do Rust. Ideally, what I'd like to do is maybe some game development with the Rust backend and some sort of Unity-ish front end or something designed, but there's a long way to get there. I want to do a backend in Rust for sure. So just state management and all that stuff, data structures, nothing too fancy. All right, so then I can take a slice. Okay, empty slice 0, sure. Arrays can be safely accessed using get. Oh boy, now they go into options and matches. So for I, obviously you can't go +1. Oh wait, there's a get method? They forgot to tell us about this. What the heck? There's a... So where do I find these documented? So Rust array methods. Okay, so we don't know what... Well, we kind of vaguely know what traits are. Aha, okay. Okay, so it has a... Oh my god, it has a ton of stuff. Transpose. No, transpose doesn't mean what I think it does, actually. I have no idea what this is. Never mind, it's nightly. Okay, there's a ton of examples here, actually. There's a map, an array of the same size. Oh, I see. You can apply a function to each element in order. Oh boy. Huh, interesting. Igor, this is very Pythonic. Yeah, it's actually very Pythonic, pretty interesting. Or... There's, of course, the try version as slice. Ah, this is what we're doing. See, I like this better. Like, I wish they did it this way. As mutable slice, because I like methods more than syntactic sugar, I guess. Each ref. Huh. Borrows each element and returns an array of references. Interesting. Why would you not borrow? Interesting. So it's like individual references to each element. Oh, I see. Oh, because you want to do a map. Oh my god, there's so many things. Yeah. Each, again, the same thing for mutability. Split array, this is nightly. Reverse split or right split, whatever this means. Transpose. Borrow clone. Alright, well, there's a ton of stuff. Okay. I'm gonna have to get used to the syntax though. Okay, so we made the thing panic, we fixed it. Yeah, the slice had 31 elements. Empty slice is empty slice. It's a bit too sugary, like for my taste. Like, I already don't like this ampersand bracket thing, for example. This is too heavy for me already. I would have preferred if, yeah, that's fun. That's exactly. It's pretty postmodern. Like, I'm more primitive. And I know it gets ugly. I really don't like it when they do, like, there's a notation where you combine the star ampersand. Like, what is this, dude? Yeah, exactly. I'm confused. Like, well, no, these are the easy cases, but I swear I saw, right, like, there's a combination of them. Anyways, I just gotta get used to it. I think it is, yeah. C, if you're used to C, but even C, I guess even C has both of them. Yeah, I'm not used to C. That's probably the problem. Yeah, I'm used to. You would think so, but I see that in code. I saw that thing. I'm not 100% sure. I wish you probably know better than. Maybe I'm confusing it with some mutability. I mean, maybe it's mutable stuff. I don't know. There's probably some weird combo. Like if you add a mute, then it also makes it different. Maybe. I'm not sure. Okay, let me go back to the Rust links now, because I feel like we're advancing pretty good in the thing here. All right, so what the heck did I do here? So the intro does nothing. So then it says I installed this Rustling thing, and it's supposed to be like for brain dead. So I press N for the next exercise. Okay. And they want you to edit the code. Oh my God, there's so much to do here. Okay, in Rust, variables are immutable by default. Assuming we know what mutability is, sure, yes. When a variable is immutable, once the value is bound to a name, you can't change that value. You can make them mutable. Yeah, thanks. Okay, so they want you to go into variables and mutability. I guess we'll give this a quick read though. I kind of don't want to do the whole circus. Yeah, it'll probably take me a while, but I think it's gonna be... can't be that hard. This is one main nudges Rust gives you right code, things are safety and easy. However, you study the option to make your variables immutable. Let's explore how and why Rust. Okay, when a variable is immutable, once the value, you can't change that. Oh, I'm not doing the whole thing, but sure. Okay, so I'm guessing this will be a compile error, obviously, because I can't change the value. Okay. Compile errors can be frustrating, but really, I mean, your program isn't safely doing what you wanted to do yet. You received the error message about it. It's important that we get compile timers when to change the value that's designated. If one part of our code operates on the assumption that the value will never change, the Rust compiler guarantees, okay, but mutability can be very useful and can make your code more convenient to write, obviously, because you would think that's what a variable is. It's in the name. Although variables are immutable by default, you can make them mutable by adding mute. Okay, so this works now, okay. Yeah, like this sounds kind of like, what the heck are we talking about here? Ultimately deciding whether to use mutability or not. Doesn't the word variable means it varies? Like, you would think most variables will be mutable. But I'm probably wrong here. It's not the Rust way of thinking. Right, that's it's called a constant, right? Like the immutable thing is called a constant, obviously, and the mutable thing is called a variable. You would think so, but not in Rust. Like immutable variables, constants or variables are bound to a name and allowed to change. Okay, so now they're gonna tell us what the heck is going on here. I mean, this is obvious. You aren't allowed to use mute. Okay, that's it. Okay, so it has to be with a global thing, which makes them useful for values that... Okay, so constants are... Okay, so assuming we know what the scope is, which is the curly braces thing. And they must also be known to the compiler, not the... Okay, this is... Okay, there is a difference here then. I understand now, because the compiler knows the constant forever... Whereas an immutable variable can be at runtime. Okay. Fair. Not the worst thing. 3 hours and seconds, blah, blah, blah. The compiler is able to evaluate the limited... Oh, I see. Actually, this is an operation. But I guess the Rust compiler is so smart, it can actually do multiplies. Which is probably harder than it sounds, actually. Not too bad. Okay, the compiler is able to evaluate the limited... So this could have been 10,800. Okay. Constants are valid for the entire time program runs. Within the scope. Again, what the heck is a scope? Let's assume we know what that is for now. Property makes constants useful for values in your application domain. I feel like they're repeating themselves here. Okay. Okay. Shadowing. You can declare a new variable. Okay, so there's some scope trickery happening here. I see, and this gets dropped here and it goes back to 6. Okay, so now we know the basis of scopes too in Rust, which I kind of knew before. So this gets dropped. Well, it goes out of scope. Let's use the right. Okay. Binds X with F5, then creates a new variable for repeating. Then within an inner scope, I think it has to do with like the notion of scope is pretty exotic to me, to be honest. Also, like I'm not. C doesn't have this, right? Or am I crazy? Maybe I am crazy? No, it doesn't have this. You can't do stuff like this in C. Like inside the scope to shadow something. Like I'm not talking about the basic shadowing, but like shadowing inside a scope inside of a function. Within an inner scope, the third let system also shadows X, exactly. And I mean, okay, I guess these are local variables. Like this is... It's kind of like a nested function, basically. Sort of, yeah. It's also more Pythonic than C. Yeah. Okay, shadowing is different from marking a variable as mute. I see, so it's just, yes, okay, fine. By using let, we can perform a few transformations. I mean, we're not gonna start writing let chains, right? Probably anytime you want to do a +1, you'll do it mutable for sure. Or maybe not. Maybe there's an advantage. The other difference between mute and shadowing is that because we're effectively creating a variable, we can change the type. Yeah, so basically you can get yourself in trouble. A program asks the user to show how many spaces they want by inputting space. I mean, this looks... Wow, this is insane code, right? Or like, why would you just do like num spaces or something? Okay, fine. The first space is a string type and the second space is a number type. Shadowing thus spares us from having to come up with different names. Because why? Sure. However, if we try to use mute, of course we get an error because we can't change the type. All right, I think we're good now. We understand variables, so let me go back to the thing. Okay, so what the heck does this thing want me to do now? Oh my god, I'm still at intro though. Wait, I'm so dumb. Okay, fix the code to print hello world. Okay, I'm basically a Rust god now, so it's print ln. And I do save. Okay, so the way this rustling thing works, it is once I save it, auto runs it for me. Okay, that's it, we're done. Next. Okay, so now we move on to 0, 1 variables. Okay. Okay, come on, dude. This is like let. Oh, where do I get this? I don't want the... Wait, what is happening here? I don't want the auto type annotation though, because that helps me cheat. Okay, so obviously it was let, but hang on. How to disable auto type Rust? Yes, exactly. I mean, that's the point of learning, right? I swear, like if it does it for me. I'm disabling these. So type toggle inlay. I don't want any hints. Control Shift P. What the heck is going on here, Rust? Rust Analyzer. Alright, I'm just gonna leave it. I don't know how to use VS Code either, so it's fine. Okay, fine. We'll leave the types in. Okay, variable 2. What does it want me to do here? So, see, that's the thing. If I scroll now, it tells me what the fix is, which is really annoying. You know what? Let me disable this now. For a while. Okay, because it is annoying me. Okay, alright. We're good now. So, change the line below to fix the compiler. I guess all I need to do is it needs to have a value, right? So 4, for example. Okay, yeah, it doesn't matter what it is. Actually, I could have done I64 too. Yep, that also. I could have done I128 too. Okay. Next. Whoops. Let's see. Same story here. I guess I can do -10. Yep, same story here. Variable 4. Let x equals 3. Don't change this line. Okay, sure. So they want a mutable then. That's the only way to do it. Okay. Next. Let number equals a string 3. Don't change this line. Okay. Fix the compiler by changing the line below without renaming the variable. This is shadowing? Yes. Let number... I guess we're not type annotating. Oh, I'm so dumb. It's number. Okay. All right. Change the line below to fix the compiler. It's a let? That's it? Oh my god, it's not? Whoa, wait a second. Const number 3? Oh my god, is it type annotation? Ah, okay, so now... See, this is why I always like to type annotate. I can't believe I fell for this. Okay, did it say that in the book, or and did I not read it carefully then, or what's happening here? Or const? It must have said it, yeah. Yeah, the type must be annotated. Okay, all right, fair. Okay, so we're done with variables. Functions. What does the README say for functions? Here you'll learn how to write. Let's go read this quickly then, because we'll just learn some syntactical sugar, probably. Functions. I mean, we kind of saw this in the learn by example, so we know how to write functions. Yeah, we know how to write functions. We also know something interesting is their order doesn't matter, which is really nice in Rust. Snake case as a conventional case. Main entry point. You'll see the FN keyword. Rust code. Here's a program. Main. Okay, nothing's fancy here. We define it by entering FN name and a set of parentheses. Curly tell the compiler where the function body begins. So there's just the scope. We can call any function we've defined by entering its name for... Okay, so this is just very Pythonic again. Another function. I guess it's any programming language, literally. Can be called from a side main function. After the main. Yeah, so we know the order doesn't matter. This is really nice. Rust doesn't care where you define your functions. Parameters. Okay, if it's a function is parameter, you can provide concrete values for them. Technically, concrete values are called arguments. I don't know why you would mention this, but sure. I don't think many people call them... Well, I guess maybe. Yeah, a lot of people call them arguments. Interchangeably, blah, blah, and the personal parameter. Actually, why the heck do they call them parameters here? Weird. The declaration has one parameter, the type of x. So when we pass 5 into another function, 5, okay. In the function signatures, you must declare the type, obviously. This is a deliberate decision in Rust design. Requiring type annotation means compiler almost never needs you to use them elsewhere. So this I agree with. I'm not going to overtype stuff. Yeah, the compiler is also able to give more helpful. Yeah, this I knew. There's yeah, there's an empty tuple because it was in the Rust by example book. I don't remember where it was, but it was somewhere. Okay. In function signature, when defining multiple parameters with commas, pretty easy to understand. This then creates a function print label with 2 parameters. The first is okay, blah blah, pretty basic. Let's try running this code. 5H. Okay, so this is a direct formatting reference with the KWArg, similar to Python again, Quarg. Statements and expressions. Function markers are made of a series of statements. See, I don't understand. They don't call it scope here. But this thing is also called a scope, right? Oh yeah, it's all double quotes. I have never seen single quotes yet. Or, oh, actually, you're right. This is the first time I see single quote. I don't know what the heck is going on here. Oh, is it a char? Like chars must be. Oh my god! Don't tell me it's a char versus a string. If you had used double, wait. I can't edit this, but it is that, right? If I put double quote here, it's a string versus a char. Okay, that is. Wait, so which one is it? This is a char, right? With single quote. If I put double quotes here, it doesn't work. Yeah, okay, well, that's insane too. Like, this is exactly the kind of syntactical sugar that I really don't like. Like, just write char parenthesis H, always in double quotes. Because actually, I hate this for Python too, because they have single, double, triple quotes. They have a bunch of others, and I don't like that either. But, like, the fact that if I get this wrong here and I use single versus double... I'm not that familiar. Okay, yeah, so I come from Python again. I believe you, but to me this is syntactic sugar. I come from Python where they're the same. So yeah, but I know the compiler will help you. It's obvious that if I get this wrong. Okay. All right, so this is a scope. But it's also a body, I guess. No, yeah, you're good. No, I'm also kidding when I say like it's insane. Like it's it's insane to me. That's what that means. All right. So function words are made up of a series optionally ending in an expression. I'm guessing an expression is the thing without semicolon that returns the something. So far the functions, yeah, have not included, because Rustin is an expression based. Okay, I've never seen it characterized like this before, but sure. Rust is an expression based language. It's important to know other languages don't have the same distinction. So let's look at what statements. Oh yeah, I'm jumping ahead. So yeah, statements are instructions and do not return. Yeah, you can write or you can expressions evaluate to a resultant. So this is a statement. Oh shit, I know what this is. So, oh yeah, of course. Oh, this is also very Pythonic because obviously there's, oh, this is the none in Python. Well, ish. Except it's enforced at compile time, so you can't do let x equals none. You could do it in Python, but not in Rust. So this... yeah. return exactly. Yeah. It's I wonder if you can chain expressions then. I think you can. And I think that's exactly what you're talking about with like yeah. The let y says does not return, so there isn't anything for x to bind to. This is different. Okay, so the assignment returns the value. In those languages, you can write x equal, not the case in Rust. This is fine. This is pretty Pythonic. Expressions evaluate to a value. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider... Wait, I'm so confused. What do you mean? What does it mean expressions make up most of the rest? Oh, it's because expressions... Oh my god, I'm so dumb. Expressions are the right-hand side, basically. Expressions can be part of statements. Calling a function... Yeah, okay. I understand what they mean here. So expressions are the right-hand side. Calling a macro is an expression. A new scope block... Yeah. This is getting into like... Okay, so yeah, this is a scope here, and it's... I guess the whole scope returns the expression. Okay, sure, which is x plus 1. And I'm guessing you'll see a 4 here. Yeah. The whole expression is a block. So statements can have expressions in them, but then expressions also can have statements in them. No, sorry, blocks. No. This is... No, it is an expression. Yes, this whole thing is an expression that evaluates to 4. And inside it has a statement that has an expression in it, which is 3. Like the plain text 3 is also an expression. And not to mention, this is also an expression. Okay, pretty basic. Possible, maybe. Which is unlike most of the lines. Expressions do not... Functions with return values. Okay, so we know the arrow operator. Very Pythonic, like literally Python. We don't name return values. Once declare their type after an arrow. In Rust, return values synonymous. Yeah, it does look extremely functional. Exactly. Quirk of the OCaml language. It doesn't want to work. Yep, it doesn't work. Yeah, because C doesn't have nested functions, right? Basically. Whereas Rust even has properly nested functions. Like you can actually define function in function. Or you can just do the scope thing, I guess. But I am having a bit of trouble understanding why wouldn't I functionalize this. But I guess it's just... it would look cleaner to me if I had an fn inner. Maybe not though, because I have to figure out what the arguments are. Functions can return values to the code that calls them. We don't name return value. We don't name return values, but we must declare their type. Oh, I see. So there's no name for... Okay. Using return, but most functions return the last expression implicitly. Oh, it does? Bear braces and close blocks. But does that do anything, or... Yeah, same here. I didn't even know that was a thing until now. Like, what's that even... Okay. Let's not even talk about that then. Yeah. There are no functions in the 5 function, just number 5. Yeah, because 5 is an expression in Rust, obviously. Why not? So it's a function that returns the result of the expression 5, which is the number 5, the value 5. The function returns type, blah, blah, blah. The 5 in 5 is the function return value, which is returns type. Let's examine this in more detail. All right, let blah, blah, blah. I mean, sure, but this... Yeah. The 5 function has no parameters. Okay, this is pretty basic, so honestly, we can skip ahead maybe. returns a +1. What happens if you place a semicolon? We're going to get an error. Oh yeah, so this is the thing you said. This is the thing that you were saying. If I make this mistake, I'm returning something empty. And I'm violating the compiler, basically. Okay, well, this was pretty easy. Comments are... Okay, that's it. All right, so we know functions now. Okay, let's see what the heck they want us to do here. Functions 1. Add some function. Okay, now it's starting to get more complicated. Add some function with the name call me without arguments or a return value. This syntactically, this is probably the hard... Okay, so this works. This looks really bad. This looks better. I guess for... Okay, I'm not going to over-annotate it. So I guess this is the answer. All right. Hey, thanks for joining on YouTube. I'm just messing around with Rust. No more AI for a while. I think this is the answer. It's got to be. Okay, yeah. It's too easy. Add the missing type. That's an interesting question. Pass. I like pass. Although I got a lot of hate at work for using it, but yeah. Add the missing type of the argument num. Well, shit. How do I know if it's i32 or i64? I'm just gonna do i64 because I want to. Right? Call me 3. I think this is gonna work. Yeah, it works. Although it could have been i32 or it could have been i128 if I wanted to. Yep. It could have been... Oh, no, wait. It could have been u64. Okay, so anything works here. A bit ambiguous. See, now they start with u8. Sure. So I got it wrong. Well, this one's easy, but there is a... Ideally, it should be... Isn't that the size of a pointer, though? Is it really supposed to be U size? Because this is not a pointer or a reference, right? Maybe. Alright, so it says fix the function call. The only trap here is that it's U8, so if I put yeah, exactly. Like, I'm just gonna use U128 everywhere just for... But is it a where's the list here? Because it's a... What am I... It's a scalar, right? It's a pure scalar in Rust. There's no underlying list here or any weird stuff. Or is it because of the slice here? Because of the range? No, this is still a pure integer, right? Because it's not used for indexing or anything. Alright, so the only... Yeah, if this was... I agree. If this would have indexed, then yes, definitely use size. It seems like it's just a pure functional print. So, okay, so here I'm just gonna put like 23 or something. Okay. Oh shit, I didn't realize it prints all the... Okay, good. The only trap here is obviously U8. Okay, maybe this is starting to look like a real exercise. Hang on, what's going on here? Oh god, the store. The store is having a sale where if the price is an even number, you get 10 bucks off. If it's an odd, it's 3. Don't worry about the bodies. We're only interested in the signatures. Oh yeah, there's the AS keyword. Yeah, I didn't get to that one either. All right, so what do they want here? So fix the function signature. Oh, I need a return type. Obviously I64 because it returns price minus 10 or 3, so it has to be I64. Yeah. Okay, well this was too easy. Next. Fix the function body without changing the signature. Oh, come on, dude. It's like num times num, right? That's it. Okay, these are a bit too easy, sure. Okay. All right, let's go to control flows. I guess I'm gonna read this. All right, control flow should be pretty easy. It's just the if. Like, come on. Okay, so I just need to know this. So it's if, else. An if expression allows you to branch your code depending on conditions. Sure. You provide a condition if this can run this block code. Run this block code. Again, are these are also scopes. I'm a bit confused about the block versus scope thing. But let's say we don't yet know what a scope is, so it's kind of okay. I think they are also scopes, right? If I were to define let something here and I go outside, I don't see it anymore. Is that true? Or like it's out of scope, right? In Rust. Or is that not all? Is that not necessarily the case for the curly brackets? Okay, it is true. Yeah. That is kind of wild though. So I think I get it why, because the compiler needs to know. I see what's happening. So okay, this is where it's drastically different. Yeah. No, that's the thing. Like exactly. No. So that's exactly the thing. So in Python, I can do if stuff x is 4, else pass, and then I can check if I guess I can't. I have to do like, what am I trying to say here? So I can do, in any case, this is valid code in Python, but I can still reference X once the if else finishes, right? No, not in Python. That's what I'm trying to say. Yeah, in Python won't, unless if you use a linter or some typing, whatever, yeah. But in pure Python, you can just do it on a branch. And then look, this also works, right? Like y is x. So this is valid Python, and it's also correct Python, right? Let's say I have some other code here that doesn't use x. I mean, it is pretty horrendous Python. It's not good Python, but but I understand now. Rust needs the compiler, and Rust wants it outside, right? So, because otherwise it would never know to match the branches. But this Python code will run, as long as the user is careful enough to, yeah. All right, so. Okay, so this is a scope and a block. Okay, fine. An if expression is going to run a condition. A condition checks when the number has less than 5. We place the blah 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 if expressions. Option we can also include else. So it's if else. Sure. Okay, I'm not going to do this. It's fine. The condition must be a bool. Okay, so this is pretty important. It must be a Boolean. You cannot, it's not like Python, because in Python also, you can do if integer, and it will implicitly test if it's greater than 0. Or non-zero, whatever it is. Is that how C works too? Like C allows you to type like if X, where X is I32. Oh, yeah, it's falsy. Yeah, you're right. Yep, falsy, truthy. Yeah, okay. So yeah, Rust is more strict, which is fine. We like strictness. That's fine. So it has to be a pure Boolean. Okay, we don't yet know all the expressions, by the way. Like I guess this is not equal just by guessing the syntax. And I guess this is modulo. Yeah, this is integer modulo, right? It's gotta be. Else if... Yeah, else if is pretty normal. In Python, it's just elif, so very Pythonic. Okay. Yeah, and or I saw those. Those are the... Yeah, this is also a state. I mean, the first hit matters here, so it's a bunch of bullshit. Like it prints the 3 or whatever the answer is. It's probably the 3, right? Yeah. Okay. Using too many else if. Oh my god, I get so much hate at work for this, so I obviously sympathize with this. So if you have more than one, you might want to refactor your code. This is literally my life every day at work, by the way. Like, oh, you used an if else, PR rejected. Okay, chapter 6 are part for us branch and match. Okay, using if in a let statement. Also very Pythonic. So this, we call this an inline if in Python. Right, so, oh, it's an expression, right? So it returns something on each branch. So you can use it as the right-hand side in a statement. Yep. Let condition true. If condition, okay, so number is 5. Oh my god, there's some typing horribleness here, though. What the heck is this? Oh, I know what it is. I mean, of course, because they didn't annotate number. Why would you... Again, I don't understand this. Why would I not write number I32? Especially in code like this, right? Like, this puts a lot of burden on the code reader to, like, figure out what the heck is this guy trying to say here. And it's I32. But the thing is, it is I32, but then you also need to read... I guess what's the logic is that I read just the first branch and I don't need to read the second one because the compiler takes care of it guaranteed, like in this case, right? But my question is different though. Like if I get this code and I'm told to fix it, I don't know how to fix it because I don't know what the programmer's intent was. Was it I32 or string here? So if somebody gives me this code and tells me, hey, I messed up, fix it, I don't know if I should change this 5 to the string 5 or the 6 to the integer 6. But yeah, that's a. I mean, I get it. It doesn't compile, so it's yeah, exactly. It's the fault of the person that. But that's the thing. If they had annotated it, they could have communicated that to me, right? If they have put here an I32, then I can fix it for them. Okay, I'm just gonna type 6 here, the number 6. But anyways, that's probably too much detail. Okay, so obviously it's typed. The expression in the F block is valued to an integer, and the expression in the else block string. This won't work, must have a single type, and Rust needs to know, obviously, knowing the type of number as compile verify is valid. Okay. Rust won't be able to do that. Okay, we're more complex. Repetition with it. Oh shit, we have loops too? Oh, I'm out of the if though. Okay, let me go back. Let me do the exercise because the exercise is only for if. Yes. Okay. Okay, I think this is the real first one. Oh my god, it has unit tests too. Sure, we know what unit tests are. Oh, they actually left the unit tests in. Oh, because they want you to know if you... Okay. Oh, come on. Yeah, but they don't tell you what tests are yet. Like, we have a long way to go. But I know what they are. Yeah, these are unit tests. And, I mean, this is why I like Rust, because it's very Pythonic. Like, even without knowing the syntax, I know what this does. Yeah. Also, yeah, it's... I think C really sucks because it doesn't have standardized testing, right? Yes. Well, I think I know what the module is. It's probably the file, or I'm assuming the module is if1, the top one, and there's a nested module in it. We gotta get to modules too. Yeah, pretty much. Like, there's no... They don't... C doesn't even... No, maybe it has an assert macro, but still. Okay, so then this is easy. So it's if... Yeah, it has a standardized assert, right? So C doesn't have that... Let's see if I remember the syntax, right? So if A is greater, return else B. Okay, that was pretty easy. Yeah, it is. It's an assert.h, but I don't know if that's part of the standard C99 or whatever. It's probably, like, you can always include that on most platforms on... I don't know actually if it counts. I've seen it before, and I know I didn't have to install anything for it. Yeah. All right, what's happening here? If the food is... Okay, so wait, hang on. So this is a string that I get in. And I need to return also a string. Oh my god, I have to read the test now. So if it's strawberry, it wants yummy. Obviously, this is wrong because we need to return the string always. That's one thing. Okay, so I have to start typing all the ifs then. I guess I can eat that. Else if... Now we have a problem here though. How do I write an or? A three-way or? Because I'm not going to write 3 more branches. Oh my god, I'm so dumb. It's else. Never mind. Well, I'm kind of reaching for the behavior here. So okay, so I'm cheating because I'm inferring that. Yeah, I strongly agree with I mean, look at this. It's so clean, right? You can tell what the function does, I guess. Maybe. So what do I do here on the... If I put... Yeah, I think this is the right implementation. If I strictly respect the tests, I should just check if it's either of these, but then I'm assuming everything else is disliked. Yeah, so this passes all the tests. Let me try that then. Let me just try a match then. Sure. Match. No, I need to read. I don't know the syntax. Okay, never mind. I can't guess it. It's I'm assuming it's pretty easy though, right? Rust match. Okay, so match left hand side, right hand side. Default. Okay. So it's match food left hand side, left hand side, and wild card. Okay, and then strawberry, potato. Is it like comma after each of these or semicolon? I think it's comma. Yeah, okay, comma makes more sense. Yeah, because these are not... oh shit. I guess I can eat that. And no thanks. Okay, but now I have another question for you because it's more... Okay, now my question is, what if I want to... So the tests don't tell me... Can I do a three-way match here? Like, does this work? A or B? Or C, it doesn't work, right? Because strictly what I need to do is I need to match these three. Oh, it's a pipe? Okay, nice. So it does work. Okay, nice. Okay, because this is actually the correct... I would argue this is the correct implementation. Or if we want to be more fancy, I guess we can put undefined behavior here or something. Yeah, okay. All right, this looks way nicer. Because it is true. Like, the asserts are... Okay, it says anything, but sure, it's the string. Okay, next one. Oh, Jesus Christ. What the heck is this, dude? Yeah, we're definitely refactoring this to matches. Oh my god, it's like an if-else... Okay, fix the compiler error. Unexpected. Okay, so everything has to return a string, and obviously these things are not strings. There's like a mix of integers and floats. Okay, I don't even want to read all this. What the heck is going on here? Identifier. Oh, so I see what's happening. So if identifier is 2, it burrows. Yeah, I figured. I mean, I'm guessing it's I'm guessing that wildcard is needed everywhere, even for integers, right? Or... It makes sense, though. It's the default case. So the habitat of gopher must be burrow. Oh, I see. Identifier must be an integer. Okay, so for gopher, the identifier is 2 because it burrows. Obviously, this cannot be unknown. It has to be -1, I guess, because it's an I32, but we're not going to I guess we don't annotate, so yeah, we know it's I32. The crab does what? Beach. Okay, so crab is matched, and the snake does desert. Yeah, okay, this should be it then, yeah. Dinosaur will be -1, unknown. Okay. All right, now let's do the civilized version where we refactor this. Okay, so now I can match directly in line. Oh, thanks for the Twitch follow. Okay, so yeah, I can do it in line like a civilized person. So match the animal with the crab. 1, gopher, 2, and everything else -1. Okay, so now this hybrid code should already work. Oh shit, it's a statement, so I need to terminate it. Okay, yeah, so then we can also do this then. And then this becomes a straight return on match identifier. So no semicolon. And 1 goes to whatever. And then 2 goes to whatever. Oh yeah, obviously. Yes, I forgot. I'm guessing Rust FMT, like Rust format takes care of these for us. Okay, and this one does not have a semicolon because it returns the string. Okay, good. This looks a lot better than that if-else festival before. All right, fine. Let's do more then. Next, one more. Okay, we're stopping at Vex, but before that, let's do primitive types. Oh my! Oh no, there's a quiz. Holy shit! What the heck is a quiz? Oh my god. Okay, we're stopping after the quiz then. Okay, so it puts them all together. Mary is buying apples. An apple costs $2. If Mary buys more than 40 apples. Okay, so now this is a real quiz. Okay, so we have to write everything. Oh god. Calculate price of apples. Okay, so quantity is obviously going to be I32. And the price is also obviously I32. Oh, this is kind of easy though. What the heck? So if quantity... Oh, it's kind of disappointing. Less than 40. Well, I made a mistake. It's supposed to be U32. You can't buy negative apples and you can't pay negative prices, obviously. So if quantity is less than 40, quantity times 2, else quantity. Yeah, this is it. Okay, well, oh no. There's no way. Oh my god, I'm so dumb. She says more than 40 apples. So then 40 is... Okay, I messed up the quiz. So yeah. So, okay. So obviously it's less or equal to... there are two, but they're way farther ahead though. No, that's it. Like, this is it, the quiz. We can move on to the next section now. Primitive types. This one's easy. We can do this one too. Rust has a couple of basic types that are recommended for the compile. Oh, we already read this. Data types and the slice type. Let me read the book again on... Let me read the book on slice types. Although we read this in the learn by example. Write a function that takes a string of words. Well, shit, this is kind of getting harder. Hang on. Takes a string of words separated by spaces and returns the first word it finds in that string. Okay, I would not know how to do this with the current syntax that I know. That seems... Because I don't know how to walk through the characters in a string. Okay, so it takes string. We don't need ownership. Yeah, so what the heck is... We could return the index of the end of the word. So this is a U size. Okay, so you decode it as bytes. And then if a byte re-encodes the space, then you return its index. Yeah, so you have to convert it to an array of bytes. The problem is I don't know these methods. Like, I have to read the string methods, right? We create an iterator over the array of bytes. And I don't know the iter either, or enumerate. Am I missing something? Like, where am I supposed to learn about iter and enumerate? Or maybe that's later in the Rustlings? Oh yeah, it's all the way in 18. Yeah, okay. So I guess let's pretend we know what these are. Sure. Oh, I see. For now, know that iter is a method that returns each element in a collection. Okay, but what the heck is a collection? Okay, sure. Enumerate wraps. Oh god, there's so many words here. Okay, let's say we know that. The problem is there's another concept here, which is wrapping, which is calling two methods in sequence. I guess that's called wraps the result of iter. So it's some sort of post-processing going on here. And I need to read the docs for these. Like, there's no... Or to memorize these, I guess. Okay, anyways, let's say this is... So if the... Yeah, it's a chain. Jesus Christ, there's so many words here. Like, seriously? So wraps the result. What the heck is a pattern? Because we get a reference to the element. Yeah, this is way too complicated. Like, so we get a reference to the element We use the... Oh, I see. So the pattern... Oh, this is just dereferencing. Okay. See, the problem is I didn't know that. What is a... No, not pointer. I know what it is now. Yeah. Okay. I guess... Okay, did I miss that? No, probably not. It's probably... Oh, no, it's here. It's... Yeah. Okay. Yeah, there's a lot of new words, but... Okay. All right, so now I understand. So it's the elements, and obviously you have to do it like this because the compiler expects it like this, and the index, and the reference to the item. Okay. Inside the for loop, okay, this logic, this is easier to understand. We know this, okay. Binary of, or the bit representation of, no, it's binary representation of the space. Okay, so we now have a way to find blah, blah, blah. Oh shit, hang on, something else is happening here. So we now have a way to find out the string, the index of the first word, but there's a problem. Yeah, you can okay, we need to learn what dereferencing is too, but yeah, I think I understand what that is. So we're returning a new size on its own, but it's only a meaningful number in the context of the reference to the string. Okay, like inside this scope here. In other words, because it's a separate value from the string, I guess they mean the reference is a separate reference string. There's no guarantee that it will still be valid in the future. Right, exactly. So then I do clear here. So then word captured something about the reference, but it's not updated, obviously, because that's not how... Yeah, exactly. So, and this is also not a compiler error. Yep. Okay, so we're starting to get close to... Okay. The program compiles and will also do so if we use word after calling as clear. Because word isn't... Exactly, so it's a statefulness thing, right? So word isn't connected to the state of S. Word still contains the value 5, which is obviously wrong at this state of the program. Managing these indices even more brittle. Yeah, so then it can get arbitrarily worse. Luckily, Rust has a solution to this problem. String slices. I feel like this is such a complicated way to learn about slices, but sure. A string slice is a reference to a contiguous sequence of elements of a string. Saying you're allowed to create cell phone variables from borrowed variables. So rather than a reference to the entire string, hello is a reference to a portion of the string, and the other portion of the string we create. Okay, so we know this. We've seen the slice syntax before. Oh yeah, they also have the metadata. Yes. The problem is I don't understand where this is going though. So with... Okay. Oh, you can also use len, very Pythonic. Okay, so from the third all the way to the... I guess you could have used slen directly here. Okay, so now my question is, how the heck is this useful for the space problem? Can I guess it? Hang on, let me not look. So, we have the problem... I don't understand. Like, the problem is to... So what? I'm gonna create a slice that's dynamic. I'm just gonna slice this into 2 parts, one before the first space and the second one after. But how does it solve this problem where if the string is emptied? No, but I don't think they're, I don't think they're going for that. I'm trying to, okay, let's see what they do, because I don't understand where this is going. So with all this information in mind, let's rewrite first word to return a slice. Okay, sure. But then it's exactly the same logic, except I return a slice. Yeah, okay, so I kind of guessed it. So I find the index manually. Yeah, exactly, yeah. So hang on, because I still don't understand how this solves the problem. That's the problem I have. So I find it manually. I return a slice, sure. If I don't find it, I return the whole thing, sure. So how does that solve my synchronization problem here? Oh my god, I'm so dumb. Is it because it's stateful now? Like it's actually tied to the S even when it returns from this? That's kind of messed up. So I take a reference and I return a slice into the original, because the slice... So again, the problem they're trying to solve is exactly this one, right? So I have a string, I compute something, and then I clear it. I would like this thing to update. So what are they gonna do? Okay, let me see what they do, because it must be this, right? So yeah, there we go. Oh no. Ah, okay, so they're gonna force a compiler error. Okay, this makes more sense. Yeah, no, it's not what I thought, because that would have been way too complicated. So we now have a straightforward API that's harder to mess up. Yeah, exactly. So they're gonna force. Okay, now I understand what they do here. Okay, this is why I need to get into the Rust mindset, because I was like, oh my god, am I gonna create like a global state and like, yeah, exactly. So I see. So word is, yeah. So the compiler catches that now. Okay, gotcha. Yeah, I really need to get into the. Okay, so anyway, this is all like we don't. Oh, you know what I'm realizing? Oh my god, this. So here's what's happening here. The problem is we started from this rustling, which told us to look at the slice type, but then this slice type, I'm just realizing it's like in the middle of the ownership section. So obviously I should have read these sections before, but lucky for me, I vaguely know what it is. So I get this now. Yeah. So it forces the code was logically incorrect, but it showed the problems to show up later. Slices make this bug impossible and let us know much sooner that we have a problem with our code. Okay. Recall from the borrowing rules, which we did not read, unfortunately, so we don't know what these are, that if we have... Yeah, I think exactly. I think I got misled. Okay. So let me check the slice syntax. Okay, so there's a bunch of syntactical sugary things here. Okay, I think let me go back to rustlings. Yeah, because the primitive types are way easier. All right. I'm not even going to read the basic data types. Okay, booleans. Yes, that I even I know that one. Yeah. So I know you can't have multiple borrows. But it's not. Yeah, I have to read the. Okay, let me go back to primitive types, because I feel like the rustling was not well written here. They should have referenced to the Rust by example section, because they have a much cleaner way of learning slices. Okay, so what's happening here? So right, they allow multiple immutable borrows since they don't have data. So yes, and then I know there's the whole ref counted, ref selfing. I have some vague knowledge about all this stuff, but yeah, let's not get into it yet. All right, so we're back to the types. Oh yeah, I know that one in Python too. Yeah, I got grilled at work for that one too, but I learned my lesson. Like the default list, the empty list argument is brutal. Yeah. Okay, so if is, what the heck is happening here? Let is morning true. Okay, so it's let is, yes, if you write a Python function that in argument defaults, it's like arg equals empty list. It's really bad. Like yeah. I'm just gonna guess it's not morning. I think this is negation, right? Yes, it is. Okay. Okay, so it's not, Booleans are easy. It's just not, maybe some logical operations, but I can always look those up if I need them until I get used to them. Okay, what's happening here? Oh, characters. Oh yeah, this is what we talked about earlier, the single quotes. Brutal. My first initial C. I guess again we have to magically know these or look them up, but sure. Is alphabetic, is numeric. Oh, this is just a mess around. What the heck is this? Like, let your character what is the empty character? Let me put it this way. Aha, it's not a thing in Rust. Interesting. Empty character doesn't work. Yeah, this one is easy. Okay. I mean, we saw earlier you can type. Oh yeah, you can type Unicode stuff too, so you can put weird things in here. I have it, but I intentionally disabled it just not to not get the hints. That's exactly what I did. Actually, even the Rustling guide says to install it. Well, no, there isn't. That's the thing. It's a compiler error. Well, I don't know if this counts as a thing, but it's not a thing. Yeah. No, but not empty string, empty char. Yeah, this, wait, so what the heck is an empty string? Oh, because it has metadata too, probably. It's not the same as an empty char, right? Well, empty char is not a thing, yeah. All right. Hey, thanks for joining on YouTube. Can I have an internship, please? I wish I had that much power, but I don't have enough power to hire people. Oh my god, what the heck is A? I know what this is. It's the so it's I32 of 200 equals 0 repeated 200 times. Okay. All right. Are higher and fire pronounced? I don't think so. I don't know. Yeah. It's interesting you mentioned Japanese though. My mind flew to Sakana AI for some reason. I'm on Twitch too. If you're watching on YouTube, I'm on Twitch. Get a slice called nice. Okay, this is not that bad. So nice slice. It's from 1 to 4 because I know how to. No. Okay. I'm so dumb because it's I-32. No, wait, it's I-32. Wait, really? Sorry, I forgot the slice syntax. Is it yeah, it's a reference. Yeah, obviously. And it's also a reference here. I forgot the syntax. Oh no, it's not. Oh, this is my problem. It's not annotated, so. So can I not annotate this then? No, I can't, right? Like, why can't I annotate it as a slice of size 3? This doesn't work? I'm a bit confused here. Can you type annotate a Rust slice when creating it? Oh, yes, I know what you mean. Okay. Just not length. Because why? The compiler doesn't have a way to... Okay, I see. So it has the length metadata. Okay. I think I'm confusing it with the vector then. Sorry, my bad. Yeah, okay. So the vector has the length. The array, I mean. Sorry, the array has a fixed length at compile time. This one has a length property, right? Which should be 3 here. Okay, well, I don't know how to experiment. I guess I'll experiment here. Yeah. Yeah, okay, so it does have the length. Yeah, reference is part of an array, but you don't have to annotate it because it has metadata at... This is inferred by the compiler though, right? Or is it... Okay, all right. Okay, maybe I'll let's move on. What is happening here? Oh God. This one is easy. It's exactly Pythonic now. So it's name age equals cat. It's like it's a pattern, right? Yeah. Okay, so this is exactly the pattern. Now my question is, do I annotate this too? Because I'm obsessed with type annotation. And I would think that, let's see. Okay, so then the type annotation is string F32, right? No. Oh my god. Okay. Yeah, this is really bad. So I messed. So it's always a reference. This I didn't know. Interesting. So it's always a reference to string. Oh, also I got this syntax wrong. Oh, okay. But I also got the string fact wrong though. Let's see, did I not? It's not that either. No, but it's not. This is a syntactical error, right? Yeah. So hang on. The syntax is... Yep, there we go. So it is the pair syntax. But yeah, I fell for a trap here. String literals are always... String literals are string slices. So let me ask you this then. If I do... can I create a string? Like I can do... Is this how I create a string? Oh, it's from... Okay. Aha, it does work now. Okay. Interesting. So it's only when it's created from a literal here, right? Well, shit. This is kind of... I guess because it creates it... I see. So this is like a shadow variable, basically, right? It goes nowhere. I know what this is. It's an expression which returns a reference to the string it represents. Now, if I do it like this... Okay. Yeah, so then if I do it the other way, this is never assigned, so I get the reference to it. Oh, no, it's still on the heap, but it's like a nameless variable, right? String, okay, so it doesn't actually exist, don't need to be created during execution. But they must exist somewhere, because I get a reference to it, right? Ah, okay, so string objects, yeah, of course. I guess if okay, I would have had to put... Okay, it gets too complicated. Okay, but I get it. I kind of get it. There's separate global constant that's different for... I see, okay. String is usually in raw data. Okay. So it is string in the original pattern. So it's a reference to that section then. Okay, all right, pretty good, not too bad. So it seems like strings are a big part of Rust. Definitely need to learn more there. And they also seem tied to... Okay, let's see what's happening here. Oh, what the heck is this? Numbers 1, 2, 3. Oh no, it's a test. What? I swear, why the heck do they write these? I'm supposed to fix the test now. Use the tuple index to access the second element of numbers and assign it to a variable called second. So it's an I32. What? It's just numbers dot one? That's it? Well, this was disappointing. Yeah. Okay. I don't know what... Yeah. Yeah, that's the only way to reach into this, I guess. Yeah. All right. Not too bad. I gotta tell you, for the first evening... again, I kind of cheated a bit because I knew some vague Rust. Pretty good. There's some control flow. Like bracket Python syntax? I don't think so. What that's what you mean, right? That would be insane. That would be like so Pythonic. Like this? It doesn't work. No. Pretty good. Pretty good, to be honest. Yeah, I don't know what you mean. You meant the operator, like the indexing operator, or the something else? Because it doesn't have the... Doesn't seem to have any bracket. Okay, so we gotta look at loops. And where were we in learning Rust by example? Oh my god, okay. So next time we'll do structs. Okay. Okay, so we did pretty good. We covered basic, very basic syntax, some slices, but we're already starting to get into ownership problems, to be honest. Where the heck does this guy talk about ownership? Oh yeah, here we go. So pretty soon. Okay. I think I kind of like... I think overall I like Rust by example more. These examples here they have seemed a bit too easy so far. There's gonna be a bunch of vex. Alright, well, I think it's time to call it. Thanks everyone for tuning in. It was pretty fun. I think it has to happen. There's no escaping Rust, so might as well take the bullet now and just learn Rust. So I'll keep at it. And yeah, thanks everyone for chatting, stopping by. Appreciate it, and we'll see you next time. Have a nice evening. Bye. Thanks for the follows.